everyone to the WREN webinar. We are just about to get started, and I'm just going to test the audio to make sure it's working. Sounds like it is. Great, so we are now broadcasting. Thank you everyone for joining. This is Paige Johnson with American Wind Wildlife Institute, and we'll be turning things over to WREN and our presenters today in just a second after I go over a few quick logistics for everybody. For sound, you should be able to hear us through your computer. If you're having any technical trouble with the webinar, you're welcome to email me at pjohnson@awwi.org. You can also send us logistics questions in the Q&A box there on your screen. And we can send you a call-in number if you're having trouble listening over the web. And just a reminder that if you're listening and you are not presenting, please make sure to mute your line so we don't get any feedback. After each presentation, we will be doing a Q&A. So if you have questions for the presenters, please enter those into the Q&A box. You can type your questions into the box at any time during the presentation, and we'll read them out loud at the end of each presentation for the presenters to respond to. And just a note that you will only be able to see questions you submitted in the box. You won't be able to see others' questions, so we will read those out loud. And lastly, just a reminder that we're recording this webinar, and it will be available on the WREN website after we are finished. So now I'd like to turn it over to Elise DeGeorge with NREL to introduce the speakers and give a little bit of an introduction.
Yes, thank you so much, Paige. Welcome everybody to WREN's 14th quarterly webinar. This topic is on reconstruction after decommissioning. It's a cross-industry perspective. Each of these webinars that we host offer perspectives from multiple nations on research, monitoring methodologies, and the results of wind, energy, and wildlife interactions. We are very happy to have Kenny Taylor from Scottish Natural Heritage presenting, as well as Dr. Deborah Luxinger with Enercon. And they'll both be discussing reconstruction after decommissioning from the offshore wind, land-based wind, and adjacent industry perspectives. We'll remind you about this later in the call. Down on the bottom is the link to the WREN Hub at tethys.pnnl.gov, where all webinars and associated presentations are archived, and you can access any of the previous webinars as well as this one shortly after each webinar is hosted. We have two speakers today. As I mentioned, I'm just going to call out a few items from their bios. Dr. Luxinger has 30 years of experience in the development of energy resources. She holds advanced degrees in environmental geology, biogeochemistry, and climatology with extensive experience in regulatory compliance. She's currently the program manager leading siting and development efforts for new renewable power generation projects, license renewal of existing plants, and natural resource regulatory compliance. Thank you so much, Deb, for presenting today. And also, Kenny Taylor is Energy Policy and Advice Officer at Scottish Natural Heritage, covering wind, hydropower, solar, and micro-energy installations. Kenny produces guidance to help with the understanding of the natural heritage impacts associated with renewables deployment and proposes mitigation to limit them. And these more full bios will also be available on the WREN Hub for you to refer to. Just some brief excerpts from their presentation is shown here. Deb's presentation will include a high-level overview of the status of the industry today and lessons learned from other energy-related market sectors. This will include coal, gas, nuclear, wind, and solar. And Kenny will discuss Scottish Natural Heritage's remit and role in the planning process for onshore wind development through discussion of two Scottish case studies. So thank you, and without further ado, over to Deb.
Thank you, everyone, and welcome to the webinar today. I'm going to talk about the fact that something we all know is that all power plants, whether it's coal, gas, wind, solar, or nuclear, do have a finite life beyond which it's not economically feasible to operate them. And at that point, we have hard decisions to make on whether to decommission or repower them. And while retirements will occur in many countries, we're expecting the majority of those to be in North America and in Western Europe. And there's really no standardized regulatory framework in addressing these decommissioning aspects. We really need to start taking a look at a bilateral, proactive approach to assure that when we reach the need for decommissioning, there are agreements and funding in place that help exist and establish the who and how and what organizations are going to assist with these decommissioning aspects. It's a very complex, long process to look at how we will decommission an existing plant, whether we're going to have cleanup issues, and all of this needs to be accomplished without placing undue burden on either the owner-operators or the landowners. And as a part of that, let's take a look at all the decommissioning, or I should say plant shutdowns that have occurred. Since the year 2000, and most of this data, of course, will be United States, since that is where I do the majority of my work. But since the year 2000, about 3,300 generating units totaling 115 gigawatts of capacity have been retired across the United States. Coal accounts for about 40% of that retired capacity. We also have 5 nuclear plants that are currently shut down and are in the process of decommissioning, and we expect to see that increase. All of this, of course, has given us opportunities to increase the amount of renewable generation, all of which is wonderful on that regard, but we still need to be concerned about some of the costs and the status of all of these plants. And so I'm going through some of this to give us an idea, perhaps of some lessons learned we should heed as we go forward in the latest wind rush in particular. If we take a look at decommissioning cost estimates, we do have pretty good cost estimates available. If you look at this whisker chart, though, you'll see that it's pretty variable. We've got pretty good costs available for coal, for gas and petroleum, a little bit for solar, but you can see that for onshore wind, solar, and solar CSP, we don't have an extensive amount of data available. And as we'll see later on, the data is all across the board. Another thing we want to keep in mind as we look at some of these costs is the concentration of land disturbance with some sources of power generation versus others. If we compare coal, natural gas, and nuclear, they're about 12 acres per megawatt produced. If we get up to wind, solar, and hydro, solar is about 43 acres, wind about 71, and hydro 315 acres, and that's per megawatt produced. So the extent of your land disturbance increases greatly as we get into some of the solar areas, although we have to bear in mind that that also is multiple land use that has, that we really don't see when we're dealing with coal plants and coal ash ponds. So what happens when we start to look at the decommissioning? Your most important decision is, what is the ultimate use of this site going to be? Environmental liabilities can continue long into the future. And most wind sites are generally returned to row crop agriculture or grazing. There are other options available, but when we look at trying to compare those with things like coal or nuclear plants, those are frequently able to be repurposed into industrial uses. They tend to be closer to city centers, whereas a lot of our renewables sources are a little more remote. So what we see is that we go cold and dark. It's the first thing that happens. The equipment is generally removed. Some of the environmental liabilities are remediated. But from a community perspective, the risk of blight is extreme when a plant is left cold and dark for a number of years. It can lower property values. Your environmental damage can be from unremediated spills or leaching can continue for a long time. So when we get to the cold and dark stage, we really have to start considering what is the long-range plan for this. And that needs to be considered well before we reach the end of the economic life of a particular facility. Let's take a look at lessons learned from oil and gas development in the United States. There are tens of thousands of abandoned oil and gas wells across the states. Many of them are orphaned, what are considered orphaned wells. They have not been reclaimed. Most of these sites have been involved in intensive land restoration efforts, including the removal of hunks of metal, the concrete pads, the roadways to thousands of well sites, and have been restored to native grasses in a lot of places. But these have all been state-sponsored restoration efforts. And it's very difficult to expect taxpayers to continue to have to pay for restoration of a lot of these abandoned sites. If we take a look just at the state of Colorado, we use bonds and revenue from fines to cover cleanup costs for orphans or abandoned wells, but that generates less than about $850,000 a year. So the state's only been able to plug and reclaim 52 orphaned wells at a cost of $82,000 each. Wyoming has reclaimed about 1,700 sites on state and private lands using tax and royalties. But this is an issue that we don't want to see continue, not only in oil and gas, but in some of the renewable sites as well. And we'll use one well-known example in just a couple minutes. If we take a look at some of these other industries, nuclear, for example, this is one of the most heavily regulated industries in the United States. Every nuclear power plant is required to set aside funds to decommission the plant when it reaches the end of its useful life. The monies collected come from the utility, they're billed into consumer rates, and they're held in a trust fund. And this is heavily regulated. The NRC keeps track of what these trust fund monies are. When we look at coal and natural gas plants, it's the utilities themselves, very large utilities, that maintain the decommissioning fund. There are a number of plants that have been left cold and dark. Recent studies on coal show that 238 retired plants, 90 are still cold and dark. And it's been incentivized to do that because they do not know what their environmental liabilities are. It's better to leave it cold and dark. We're seeing more and more repurposing of these sites, going to conversion to combined cycle gas, or in some cases, some of the industrial sites have really resorted to putting in small wind farms. They've put in small solar fields, so there's some tremendous opportunities to repurpose some of these sites. But again, you have trust funds available. Utilities should have funding available to deal with these types of decommissioning. So what is our problem definition when we're talking about wind? If we take a look at abandoned wind farms, we will talk about that in a minute, but we have about 4,500 abandoned turbines in California. The three big wind farms that went in at the first wind rush in the 80s Altamont Pass and Gorgonio Pass and Tehachapi. And if you take a look at this one drawing or one photograph down here on the lower left, it is very reminiscent of the oil field photograph that we looked at earlier. Now in Altamont Pass, roughly 1,500 of the smaller turbines have now been replaced with 82 larger units. And this repowering is gaining popularity, at least throughout the United States. We have a number of companies, including Pacific Core here in the western U.S., who are going in and repowering their existing wind farm sites. They're putting in new nacelles, rotors, turbine blades. They're increasing the production megawatt output for all these plants, and that is a fabulous option if you are able to do that. So if we look at this second wind rush, this is a previously unimaginable scale. I don't think anyone anticipated back in the 80s that if we saw another wind rush, that it would be at this scale. If we look at assuming a standard life of 20 to 25 years, 29,000 wind turbines will reach the end of their useful life. And costing on this has been incredibly interesting to try to track down, because costs are all across the board, and sometimes they include just the turbine, sometimes they include the turbine and the concrete pad, sometimes it takes into account all of the ancillary structures and features, but it's all rolled into a per turbine cost. And we'll take a look at some of the comparisons here. In the United States, again, looking at this example, between 1980 and 86, we added about 1,265 megawatts of installed capacity. Look at the difference in installed capacity in 2002 through 2012 and through the first quarter of 2018. So we have 41 states plus Guam and Puerto Rico that have a huge number of wind turbines going in if they're not already there. State incentives in the first wind rush really put California at the forefront. Now we're seeing it all across the country instead. In this second wind rush, now of course the first one kind of died out because the price of initially kicked off because the price of oil rose to unprecedented heights. But as the decline in oil and natural gas price continued to drop in the 80s, that ended the federal tax credits. We are seeing a great expansion with the subsidies now. However, technology has advanced, as we all know, to the point where we can now compete economically with conventional generation sources without subsidies. So as these subsidies begin to phase out and we take advantage of these tremendous technological improvements, I would expect to see this trend continue. The other big difference in looking at turbines that are left over from the 80s versus the new ones going in, it has to do with the size. We're now looking at, in 1985, a typical rotor diameter of about 15 meters. Now we're looking at rotor diameters of 164 to 190 meters, and I believe Vestas has a new offshore turbine that will even have a greater rotor diameter. So this, of course, brings us into a situation where we may have fewer turbines per wind farm site, but they're also going to be larger, greater sweep, much more difficult for installation and decommissioning. One thing that is often not considered in the decommissioning process is the fact that over time, a new ecosystem has established during the life of the wind farm. This is also true of transmission lines, and any linear project, as well as open space fields such as we have with wind farms. So when we're decommissioning, we're reversing that whole construction process. This causes a lot more damage to land that may have previously come back into grassland on its own. It may still be used for grazing, it may be used for some crop agriculture, but for the most part, you have a whole new environment out there. And in order to get in there, if we're going to decommission it, we're going to be not only removing all the installed power generation equipment, but also above ground and subgrade structures. You know, foundations can extend fairly deep underground. We may be removing substations, certainly support buildings, equipment storage areas, and access roads. And this is over a fairly large acreage area, and regrading, topsoil replacement, reseeding to get the site back to its original, or as close to its original land use as possible, could be a very time-consuming and costly process. Here is the best example that I'm sure everyone is familiar with, is the Kameoa wind farm in Hawaii. And when this was taken out of service in 2006, it just sat idle for nearly 6 years. And I think the most frustrating aspect was that the owner of this particular wind farm was in the process of constructing a new 14-turbine wind farm several miles away. And we've often considered that the salvage value will help to pay for the decommissioning costs. However, salvage value is not going to cover removing foundations and roads and regrading and reseeding. And when they finally removed these turbines, it was at a cost of $1 million, and their salvage value was only $300,000. So where does that additional funding come from? If we take to heart lessons learned from some of these other industries, we will start establishing our decommissioning funds at the beginning of the project so that we know that funding is available at the end. To decommission some of the turbines, some of the cost estimates are showing that as these are approaching life end, we may be looking at a minimum of $725 million. Where is that going to come from? Costs are continuing to accumulate. We also have issues associated with private landowners versus federal leases. This is a big difference compared to other power generating sources. Things like gas, coal, nuclear, those utilities tend to own that land, and it's much smaller acreage. When we're putting in our wind farms and our solar fields, we're leasing that land. We may be leasing it from a farmer, we may be leasing it from the federal government, but it is a different arena that we've moved into as we look at decommissioning sites that are not necessarily on land that we own. This is just a sampling of some decommissioning cost estimates for onshore wind that was available. And you can see here that it's quite variable. We are looking at different states. We're looking at different sizes of wind farms. Jericho and Arkwright are about 78 megawatts. When we get to Marble and Odell, those are 200 megawatt sites. But notice that upstream is also about a 200 megawatt site, and significantly different cost variability than what we see in number 9, which was about a 600 megawatt installed capacity site. So you should have a feel for how difficult that this is to try to get a good handle on what this is going to cost us to decommission these sites. Here's another example, and this is just from the state of Maine, where we can take a look at what the cost per turbine was, what the salvage value was, and again here where we're looking at cost per turbine, this also included ancillary features such as not just the turbine itself, but support buildings, connections, roadways, things like that. But look at the variability we see in terms of the cost, the salvage, and what the additional funds were that they may have needed to come up with to cover that. You know, and as we consider this, we have to think about the difference in what type of turbine was installed, what the location is, what the timeline is, how quickly are they going to want to decommission the site, do they have some state requirements that they have to meet, and that all those variables come into play. An additional consideration is trying to estimate the salvage value. We have encountered situations where the high-value, low-cost components have been decommissioned, but the rest of the site may be left essentially cold and dark. The concrete, there's no real value in trying to remove the concrete, so people tend to leave some of those things in place. So how do we deal with that? From a private landowner's perspective, of course, there is an incredible amount of information available from various attorneys on how they should negotiate those leases. But again, it comes down to not putting an unreasonable burden on us as owners, operators, and developers as well. So trying to find this happy mix has been, I think, a big challenge. Let's take a look at the salvage costs, historical steel scrap values. This is in 2011 metric ton. But if we take a look at 1980, which was essentially the first wind rush, where we have scrap metal at about $251, and we look at what it had dropped down to in about right before 2010, about 2009, we're down to 126. So the poor people trying to actually recycle this and take advantage of scrap, it's a very difficult situation for them when we see these dramatic changes in costs. Now, take a quick look here at a couple of different aspects of regulatory oversight. Of course, there are no overarching federal regulations in the United States. We do have 3 state regulation categories we can consider. We do have states that do require decommissioning, but no financial assurance that the money is going to be available to do that. Law of the lease states, that is all on an individual basis. And we have a few states that do require operators to post a bond, provide some sort of fiscal responsibility. Oklahoma, Oregon, and Indiana are the most notable in that regard. Interestingly enough, there are some municipal ordinances as well, and while we normally think of municipalities as being focused on local zoning, permitting, construction, special use permits, DOE has actually identified 549 municipal ordinances currently in place, and 143 of those do have restoration requirements. So we are starting to see from a governmental level an increase in attention on what should be required for reclamation and restoring some of these sites if we're not going to repower. If we take a look again at our private versus public lands, options for the surety of availability of funds, there's escrow accounts, there's bond decommissioning costs, there's set-aside funds from your energy sales. Federal agencies do have rules, the BLM, Bureau of Land Management here in the West. They require a $2,000 bond on towers and a $10,000 on Met towers and a $10,000 bond on wind turbines, and they review these bonds every 5 years. So this is a fair and safe way to assure that as we are putting in these sites, we do have the funding available to do decommissioning if it comes to that. As we move forward, I think that there are some items required. probably a statewide basis if we're going to take a look at any regulatory requirement at all. Statewide is better than the federal oversight. We have to come up with a clear definition of what constitutes actual decommissioning. Maine, for example, says that decommissioning is required if no electricity is generated for a continuous period of 12 months. Oklahoma's Wind Energy Development Act requires decommissioning within 24 months after abandonment of the end of the useful life. So in this case, we do have some pretty clear definitions of what those triggering events are, and we have to come up with a fair way to allocate decommissioning responsibility as we go forward. And thank you for your time.
Great. Thanks so much, Deb. So if anyone has any questions, please go ahead and enter them into the Q&A, and we'll give everyone just a second to think about and type their questions. We have a few minutes before we need to move on to the next presentation, if anyone has anything they'd like to ask. All right, well, oh, let's see, we've got one coming in here. Great. The question is, how many wind projects have been decommissioned?
Oh, that is a really good question, and one I do not have at the tip of my tongue. I would be happy to look that up and get that information back to whoever is asking.
Sure. That sounds great, and I'd be happy to pass that along. And
thank you. I appreciate that.
Yeah, absolutely. And we've got another question come in. Do you have any estimates for the cost of recycling wind turbine mechanical components and or blades?
I do not have costs on the recycling of them. Most of what I'm seeing is salvage cost for the metal components. I have not seen costs on trying to recycle, reuse blades. That doesn't mean they don't exist. I just haven't found them.
Great, thank you. The next question is, besides cost, what are other issues associated with decommissioning, for example, land use?
Well, I think the biggest issues are coming to agreement on what the ultimate land use will be for that site. If you're decommissioning on private land, you may be dealing with a rancher or farmer or a landowner who really just wants it returned to native grasses, or they intend to put in row agriculture. If you have community involvement, a wind farm, for example, that is in close proximity to a demand center, I think there's tremendous opportunities to work with the community to turn that land into walking trails, parks, wildlife habitat. You've got so much wonderful open space that is generally available for wind farms that could be converted to community use and park use if there is not another use that the landowner is going to insist upon. Does that answer the question?
Looks like yes. They have responded yes. Thank you. All right. Next question: are the blades and metal components the only recyclable parts of a wind turbine? And the asker is saying that they saw the cost in the market to recycle steel, but is the market attractive for other parts to recycle?
Oh yes, there's attractive recycling options for any of the metal components. I mean, you have a lot of wire, you have copper line. If you actually do remove your foundations, You have a lot of rebar and metal components that are in the foundation itself. You can recycle any of your electric line that has been used for connectors. In some cases, you're removing an entire substation, and all of those electrical components generally can find use elsewhere. I think I recall actually one site where there was sufficient concrete that they were able to, very, very low return, but they were able to actually provide that concrete to a highway department that was, you know, chopping up the concrete up and recycling it to use in a roadway. But I've only heard of one instance of that type. But that's another good example if we could get creative with how to recycle all these components. You also get situations where people cannibalize. That happened in Hawaii with the Kameoa wind farm, where the owner-operator, they had another site that they were constructing, so they were able to go in and take various components off of the non-functioning turbines and use them for the as backup materials for the new wind farm site.
Okay, great. The next question is reuse of the land for continued generation, perhaps with the same turbines or new turbines, ever considered?
Yes, it is. It is considered. That's part of the repowering effort. And that is one thing that we have a number of projects of that type going on here in the western United States, where they actually are going in, and in some cases they are just replacing blades and nacelles and rotors. In other cases, they're going in and putting in whole new towers. So the wind farm is going to continue to operate as a wind farm. However, it's going to increase the megawatt output by changing out the turbines themselves.
Lease, may I come in there? Jenny Taylor.
Is that Kenny? I think you're you're a little quiet. Could you speak up a little bit?
How's that? Is that better?
Yeah, that's a little bit better.
Yes, I'll cover some of that in my own presentation about repowering. We foresee a good deal of activity likely in the repowering sector in Scotland because of the way our planning policy and energy strategy has been written. I'll cover some of that. But on that last question about cannibalism and reusing turbine blades, we had a repowering case on one of our islands where 3 turbines were removed and shipped to Eastern Europe completely for reuse out there.
Great. Thanks for letting us know that. We have one more question that's come in for Deb. Why wasn't decommissioning considered in the 1980s? Isn't decommissioning considered with most engineered structures?
Unfortunately, it is not. In many cases, if it is not mandated by regulation, then it is not always considered. I hate to say that, but that seems to be the case. And I think when all of the original turbines went in, we were expecting them to continue to operate, and decommissioning just was not something that was considered. We were actively involved in the research aspect and what's going to work and what isn't going to work, and trying to generate power to get away from the high oil and gas prices. I think that we have become so much better over time in terms of considering what we need to do with land, multiple land use considerations, and returning the land to a more natural state, I think has evolved over time. It's part of the lessons learned. And perhaps Kenny will address that it has been better thought out in Scotland and some of the places in Europe, but it was not a big consideration back when these first wind farms went in the United States.
Well, thank you, Deb. I think we are ready to move on to Kenny's presentation. If anybody thinks of any questions for Deb that come up during the next presentation, just let us know in the Q&A box who to direct the question to. And Kenny, I'll pull up your PowerPoint so you can get started. All right, take it away.
Thank you very much. Is that a good volume?
You're sounding good to me.
Okay, great. I'll go with that. So thank you for the opportunity to speak today. So I'm going to talk about the situation in Scotland. And I will start with a little background about Scottish natural heritage, who we are, and what we do. So as you can see, we are established in the early 90s. We are a non-departmental public body of the Scottish Government. We're fully funded by the Scottish Government. And essentially, we are the advisors on the natural heritage to the Scottish planning system. We try and offer advice on potential impacts from developments on the natural heritage, including landscape, recreation and access, habitats and species, and we offer mitigation options for developments across all types of developments. As you can see, we're about 700 strong in members of staff. We're split into 3 directorates within the organisation. So we have an operational staff, and they deal with local issues dotted around local offices in Scotland, from the very northern Isles down to the border with England, and east to west. So they deal with local land management issues, protection of land, local species issues, etc. We then have a policy and advice directorate, and that covers the background, offering the knowledge and scientific evidence, the evidence base on ecosystems and biodiversity, people interacting with nature, wildlife management, coastal marine issues, our protected places, and planning and renewables. And the third directorate is the business and administration that keeps it all intact, I suppose. So we offer advice at a strategic and national level. We talk to the Scottish Government. We offer advice on their plans and policies. But we also work at a development management level. So that's individual planning application level. And as planning is a devolved matter in Scotland, that's quite important up here. But it's important to remember that energy is not a devolved matter in Scotland. So that is a Westminster, that's a London or a UK government kind of policy sector. So we can influence things in planning, but the Scottish Government has to go through the UK to influence things on energy, policy on energy. However, that doesn't mean we can't write our own energy strategies, and I'll get on to that shortly. So there is our vision. We are a government agency charged with conserving and enhancing the natural heritage of Scotland. And just draw your attention to the sustainable management part there at the end. That's a key phrase for us, and it's embedded and established throughout much of the Scottish Government's ambitions and visions. Sustainable management, sustainable economic growth. So the Scottish Government very much minded to the benefits that the natural world brings to Scotland in all parts, in all kind of sectors across it, tourism and energy, education, health, etc. So really striving towards maintaining the natural heritage of Scotland and the benefits it can offer, along with allowing development to take place. So first of all, this is an extremely messy map, and apologies for that, but what it shows is the level of protection offered across Scotland to the natural heritage that's within Scotland, ranging across its habitats and species. And I wanted to bring this up just to show you the level of protection that's been established in Scotland and that development needs to take account of when schemes come through and proposals come through. So we have a very scattergun approach to developing onshore wind in Scotland, and you can see that that can come up against protected sites, and that's not to say that there are no-go areas for development in Scotland, but it makes the assessment and survey requirements for developing out a wind farm more onerous. So SNH have a duty to ensure the protection of huge swathes of the make-up landscape and species of Scotland. And the protected areas that you can see there on the map, it covers some 20% of our land area. So going down into the different colours, you have red in there, and there are sites of special scientific interest. That's a national level designation, and that's protecting species and habitat. Really the premier examples of certain species or certain habitats, or very rare and sensitive ones, and they are good places to study and understand how natural systems are working. They cover about 1 million hectares of Scotland, or about 13% of Scotland. Some of the blue rivers, you can see the branching rivers there, and the purple shading areas, they are European level protection, so that comes from European directives to do the same essentially as the SSSIs do, and they preserve all sorts of aspects of our natural heritage, including birds, and their special protection areas are protecting a lot of our bird species and offshore birds coming onshore, and the blue areas are protecting habitats and species. For instance, entire river systems where we're trying to protect our salmon and lamprey. We've got national nature reserves, and they're protected under our planning laws, and they are a prime example of, again, excellent examples of nature, real kind of showcase pieces of peatlands and uplands, raised bogs, forests, and they're a great place for people to interact with nature as well. So we've got about 130,000 hectares protected from under national nature reserves. And finally, national scenic areas. Everybody rates Scotland as a very beautiful country, and the very prime, again, the very prime of our landscapes are protected under this designation, national scenic areas, and that covers about 1 million hectares of Scotland. So all in all, it's a fairly well protected environment. We haven't added all the local landscape designations and historical or cultural protection or areas of wild land, etc. What is clearly missing here on a map of this scale are the species that are protected, both at a European level. So for instance, all bats are protected in Scotland and across Europe as European protected species. That's legislation that protects them. and at the national level, including a lot of our birds and our mammals. So just to say, developers need to be aware of potential impacts at all stages of their scheme. That's including construction, operation and decommissioning. And our environmental impact assessment legislation, the procedures within them allow this to happen and allow developers to understand what their site might impact on and what possible mitigation they can offer. So more on this shortly. So how do we marry protection of the natural heritage and development? Scottish Natural Heritage states that it sees renewable energies as one of the key aspects of decarbonising our society. It's the benefit of energy security, and it sees climate change as a real threat to the wildlife in Scotland. So we very much support development of renewable energy. However, it can't happen in all places, and clearly the natural heritage and the benefits we get from that can't be impacted. So as an organisation, we help to enable the right development in the right place. Recent research indicates that the natural environment contributes to around £17 billion annually to the Scottish economy through farming, fishing, forestry, tourism and renewable development. And the question is, can these coexist? So it's no surprise then that the key role for SNH is making sure the valuable resource is used in a sustainable way so that this contribution can continue. And our work in the planning and renewables team and working with the renewables industry is a good example of where the role supports economic development in Scotland, which is very much needed. We've got some very rural parts of our country and quite poor areas, and renewables offers obviously a lot of jobs, etc., but still maintain our remit of protecting the natural heritage, which is very important. So let's just focus on some of the figures and some of the installed capacity of onshore wind. I was quite amazed by some of the figures that Deb was highlighting in her presentation there, and we can't quite match them, but we are relatively. It's all relative, isn't it, with the size of country, for instance. So if you look there, you can see onshore wind, which is the green bar on the right. We're up to about 7,000 megawatts of installed capacity. If you were to go back to 2000, and we didn't have an initial rush like America did. In 2000, we had less than 100 megawatts of installed capacity. So in the last 18 years or so, we've seen a huge growth in the onshore wind sector. And obviously all the roads and infrastructure and supply chain that goes along with that has had to grow as well. And essentially, all that development has come from private investment company development. The Scottish Government has been very supportive of that growth, but it's been a private investment that has driven it. So it's just to bear that in mind. I know we're talking about onshore wind here, but I'd like to point out the little orange section on the left-hand side of that bar, and that's hydro. And in the 1950s and 60s, we had a similar boom in renewables, I suppose, and developed a huge amount of hydro in order to power the Highlands of Scotland, which didn't have a lot of electricity across a good part of it, and that went in there. And there are still ongoing issues with pipes and diversions of rivers that we're dealing with today. So long-term legacies associated with large-scale development of this type. So this next graph just shows the amount of renewable energy in the planning system, waiting to get approval or waiting to be built or under construction at the moment. And you can see it's the graphs on the far right, which shows we've still got a great deal of development sitting in the system ready to go ahead and waiting for approval or waiting for the infrastructure and the groundworks to go in to start putting turbines up. So still an awful lot of work to go. And I suppose combined with the last slide, it just shows that likewise Scotland has a very large number of turbines in the ground or waiting to go in the ground, and that means a huge amount of decommissioning or repowering opportunities in the future. So how is all this being controlled? As I say, it's private investment, but they have been guided by a Scottish planning system, a devolved Scottish planning system, so planning departments within the Scottish Government and within our local authorities, when, like our local governments essentially, into the different areas across Scotland, have control of the planning system. But at a national level, the Scottish planning policy sets out our national planning policies, which reflect Scotland's ministers' priorities for operation of the planning system and for the development and use of land. So their key planning outcomes for Scotland are a successful, sustainable place, supporting economic growth, regeneration and the creation of well-designed places, a low-carbon place, reducing our carbon emissions and adapting to climate change, and a natural resilient place, helping to protect and enhance our cultural and natural assets and facilitating their sustainable use. So you can see all the things I've mentioned so far in my slides about protecting the natural heritage, but allowing development and lowering carbon, all coming together in Scottish planning policy, which is useful. So the SPP, the Scottish Planning Policy, promotes consistency in the application of policy across Scotland whilst allowing sufficient flexibility to reflect local circumstances. And I'll just read you what the Scottish Planning Policy says about wind. Specifically, it says planning authorities, and you should read that as local government, area government, should set out in the development plan, so each area writes a development plan, to direct and steer a spatial framework identifying those areas that are likely to be most appropriate for onshore wind farms as a guide for developers and communities. The spatial framework is complemented by a more detailed and exacting development management process where the merits of an individually proposed scheme will be carefully considered against the full range of environmental, community and cumulative impact. It goes on to say areas identified for wind farms should be suitable for use in perpetuity. That's a key phrase that was written into Scottish planning policy. And I suppose it suggests that once you have your site permitted for wind, then it should have a long-term life as a wind farm, and that land is therefore, the use is therefore suggested that wind is the right, it's in the right place and it should continue, which suggests repowering essentially. Consents may be time limited, but wind farms should nevertheless be sited and designed to ensure impacts are minimised. So in Scotland, as Deb was saying, likewise we have 20 to 25-year lifetimes for wind farms, and that's how consents are written for our onshore wind. So the energy strategy that was written just last year and published by the Scottish Government, it talks about a vision that strengthens our international reputation for sustainability. As an ambitious country of outstanding natural beauty, determined to build on our reputation as a renewable energy powerhouse. So they're not hiding from their ambitions and their keenness to promote onshore wind. And this is a strategy that will last through to around 2050. Finally, we have an onshore wind position statement that supports and supplements our energy strategy. And again, that outlines the Scottish Government's position, one of clear support of repowering at existing sites. But again, it says, while recognising calls for repowering applications to be subject to a clear and distinct assessment process, we propose to continue to discuss and assess the right approach to such applications on a case-by-case basis. So there's not a general broad sweep of a presumption for repowering on each case. It just has to be looked at just after 25 years, as Deb said, things may change on site. So yes, we would like to see repowering, and that's set out in our Scottish planning policy, but each site has to be on a case-by-case. So just to explain very quickly, Scottish Government give permission for wind farms in Scotland that are over 50 megawatts in size, in power output. Below that threshold, the local planning authority, the local government issues the permissions. So that's quite an interesting little tweak of our legislation, how our legislation works. Both use the same level of assessment, but there is a difference there between a national government consenting something and local authorities understanding the local issues, giving permission for small scale. With these conditions and consents, there is usually a condition in the permission regarding decommissioning, and they usually ask for a decommissioning and restoration plan to be produced in the years running up to the end of operational stage, and often for the removal of all on-site infrastructure down to 1 metre. So that is actually written into the conditions of our wind farms. So that may not be going on in other countries, but we've written that into ours, which is quite useful. I'll talk about that as we go forward. So hopefully I've set the scene for highlighting that Scotland is ambitious for onshore wind, but also recognises the benefits of our natural heritage. Our planning system has been good at enabling development using environmental impact assessment to guide the siting and design of wind farms, but that takes us on to the question of decommissioning. So just give you a brief outlook. This is SNH's involvement in decommissioning to date, and we've had input from all sorts of third parties like academia and the industry itself and the public and local communities and their interest in decommissioning. So we ran a workshop, a sort of national workshop back in 2012 to get the stakeholders together and discuss what decommissioning should look like across Scotland, and to discuss some of the terminology around decommissioning and repowering and refurbishment and life extension and that sort of thing. So that gave us a clear steer of where we wanted to go with decommissioning. We then commissioned a consultancy to produce research and guidance on restoration decommissioning, and that went a little beyond SNH's remit of considerations of the natural heritage impacts, and it talked about costings and recycling of material. And you can find that commissioned report on our website. We then wrote some guidance called Decommissioning and Restoration Plans for Wind Farms, and this basically is a piece of guidance asking developers to produce a plan on the back of the environmental impact assessment findings that's undertaken during the planning application stage. That asks people to consider the long-term impacts of a wind farm and start writing a plan to outline how they intend to decommission, and a plan that can be updated throughout the operational life of a site, so that when you come to decommission your site, you're in a better position and have a better understanding of the habitats and species using the site, and therefore a clearer idea of how to decommission whilst minimising impacts on those species. And most recently, we are producing guidance and had more discussions about the baseline assessment for decommission and repowering of wind farms. And it's that I would like to move on to next. So as I mentioned before, we only have one example of a decommissioned and repowered wind farm in Scotland, and that was on one of our Orkney Islands in the very north of the country. And the company there took down 3 redundant turbines. They had run out of spare parts for these turbines, and the manufacturer had ceased manufacturing. And so they took down 3 redundant turbines that were only 8 years old, but they shipped them off to Eastern Europe, where apparently they did have parts, and they replaced these 3 with 5 newer turbines. So that involved some more road infrastructure and new turbine bases and crane pads, etc. The wind capacity, the capacity factor on Orkney is in the high 40s at times. It's incredibly windy and flat islands up in the North Sea, where the North Sea meets the Atlantic essentially. So that was an interesting case study a few years ago. However, this case study that you can see on this slide now is a proposal called Tangi Wind Farm. It's an extension and repowering proposal, and that's happening right now on an existing first-generation turbine. And I'll read you through. So it is occurring on our west coast in an area called Argyll, and the original wind farm at Tangi has been in operation for almost 10 years. It comprises 15 turbines with a 7-turbine extension which became operational in 2007. And what I'll do now is I'll illustrate our preferred position on the assessment requirements for the repowering proposal. We have submitted this as a response to the Scottish Government, so they are aware of it. It is in the public domain. However, the guidance that is supporting it is not published yet, and we are consulting on that guidance this summer. So look out for that if you're interested in that. But I'll read you through the case study. So the proposal would repower and extend the existing Tangi wind farm, which comprises 22 turbines of 75 metres to tip. Under current planning conditions, the existing Tangi wind farm is due to be commissioned in 2022. In June 2015, the local government granted planning permission for Tangi 3 wind farm, which comprised 15 turbines to 125 metres tip height, on the same site as the current proposal. Construction has not yet started in relation to that new permission, and according to the decision notice, the planning permission is valid until 2018. The current proposal within the working title of Modified Tangi 3 Wind Farm would be for the same 15 turbine layout, but with 1 extra turbine, and that was resubmitted for and granted in 2015. So therefore, we've got a new proposal essentially on top of an old proposal, and we've got a bit of an extension added on. Our response to the planning application, which was written in 2017, suggested that the environmental impact assessment on the site, on the repowering proposal, should appraise the full effects of the new proposal. This would allow decision makers to weigh this aspect against all other material considerations, including the current use of the site as a wind farm. We believe that such an approach best reflects the intention of Scottish planning policy to achieve the right development in the right place and not any development at any cost. A comparison of the effects of the new proposal with those of the existing wind farms will be helpful to decision makers, but we advise that this should be separated from the approach to environmental impact assessment. It could, for example, be presented within the application. So essentially what we're saying is we believe that a repowering proposal should take the baseline for assessment as no wind farm. So as if the previous first generation wind farm has been taken down and the site fully restored. Now the industry are not in complete agreement with us on that, so that's quite an interesting position. So we'll be interested to hear what the consultation responses come back with on that. So there are landscape implications there, and there are bird impact implications there. But essentially we think that because the planning application permission is only valid for 25 years, that wind farm should come down and be restored, and then you assess the impacts of the new wind farm. It shouldn't be an incremental change from the first generation to the second generation. So, sticking on the theme of repowering, and this proposal, like Tangi, for higher turbines and often fewer turbines, I'd like to come on to a second key theme, which is turbine height and lighting. So in 2016, an organisation called Scottish Renewables, and that's an umbrella industry organisation that is the voice of the renewables industry in Scotland, published a document called Onshore Wind in Scotland. And essentially, they said, amongst other topics, the chapter on smarter planning highlighted 3 interventions that could occur in Scotland that would change the way the industry went forward towards subsidy-free energy. And I would like to focus on one of those interventions, and that is the unlocking of the cost reduction potential of new, larger wind turbines. Essentially, the document said, in order to be subsidy-free and this industry to continue in Scotland and to deliver energy, we need to go higher and we need taller turbines, essentially. However, as I noted in earlier slides, Scotland is a country of high beauty and protected landscapes, and taller turbines just may not be suitable in all areas. As our Energy Minister has stated numerous occasions in the past, Scottish Government will support taller turbines in certain locations where they are appropriate, and planning should manage this. So again, this is an issue that we're facing with potential repowering proposals. Scottish planning policy states that sites should be used in perpetuity. The industry are saying we should have taller turbines, but the landscape may just not be able to cater for them. The landscape character assessments indicating that we have very sensitive landscapes across Scotland. The picture on the right-hand side of the slide there, the very dark one, indicates another issue associated with high turbines, taller turbines, and that is turbine lighting. And again, there is issues and potential impacts there. The Civil Aviation Authority require turbine lighting on all turbines greater than 150 metres in height. But in our wildland areas, in our very rural areas, and in our dark sky designated areas where we don't have any kind of urban lighting, turbine lighting is clearly a new impact, and it has landscape and visual impacts, and it also has insect and bird and bat implications as well. So we're producing some guidance on that and working very closely with the Civil Aviation Authority to try and steer a line of radar rather than lighting. And we're also producing back guidance to look at these issues as well. So look out for that in the coming months. Lastly, I just wanted to cover a very key theme that Scottish Natural Heritage offers advice on, and that is peat soils. So for those who are not aware, peat soils cover about 20%, upwards of 20% of Scotland. Peatland is a very wet, very dynamic landscape. It's often low-lying, although it does cover and roll over the hills in our uplands. And it forms a very anaerobic, acidic soil material that lies below the water table. It's an incredible carbon sink, and it's very habitat species and vegetation rich. So it's a habitat that we're very proud of. There's not much of it left in Europe, and we have some prime examples in Scotland. It has all sorts of other benefits like water purification benefits and supply benefits, flood management, and we do a lot of our sheep grazing recreation across it, and sporting activities like deer management and that sort of thing. However, the problem with peat is that once you start to excavate it, it's terribly hard to manage, and it doesn't have very good engineering properties. And also, once you start to excavate it, it starts to release its carbon. And if it doesn't have engineering properties once it's been excavated, then it can be classed as a waste under our waste legislation, which our Environment Agency looks after. So the picture you're seeing here is a quarry opened up for the roads on a wind farm, and peat being put into that quarry as a sort of long-term storage option, which we don't agree is good practice. And essentially you're losing carbon there to the air as the top levels dry off, and to the groundwater and other surface water drainage through the drainage and hydrology that exists on that site. I've known reasonably small wind farms of about 30 plus turbines to cause the excavation of about 1/3 cubic meters of peat. So having to deal with that peat is a big problem for developers. So we've produced some guidance on that, and we continue working with the industry. There might be options in repowering for the reuse of peat, for instance, refilling turbine holes, excavated turbine holes, and restoring old tracks. But long-term storage of peat is a difficult management undertaking, so there's all sorts of issues there. We tackle the carbon issue on wind farms using a carbon calculator that's been developed by academia and Scottish Government, and that allows developers to put in the carbon quantities involved in all the aspects of building a wind farm, and allowing the decision makers to use that as a material consideration in their final approval of the site. So that talks about carbon payback and stuff like that. So that has to be thought about. So on that theme, the last piece I will talk about is reusable turbine bases. So a great deal of our turbines are built in our uplands and peat-rich environments. Peat can grow to a depth of 12 meters plus, and that's a tricky substrate to build large-scale infrastructure in. And we want to limit the amount of excavation going on with turbine bases, as I've mentioned. So we have commissioned some research on how usable turbine bases are after first generation, and what you might have to do in terms of engineering to augment existing turbine bases or produce turbine bases that can last further into the future. So the report, which is written by Glasgow University in partnership with ourselves and others, is due to be published over the coming months, and I will send Lease a copy as soon as I get that. So you can see here the sort of scale we're looking at: huge turbine bases, huge amount of steel in there. It's very difficult to break these out. and they are in very inaccessible sites, so a lot of transport implications associated with that. So if we can reuse the bases, that would be ideal, because you're really limiting the space available on a small site if you've got turbine bases of older generation wind farms dotted around all over the place. So I hope that's given you an insight into Scottish natural heritage and the industry in Scotland going forward, and the sort of planning and thinking we're putting into how we maintain energy generation in Scotland, along with minimising impacts on the natural heritage as we do so. Thank you very much.
Thank you so much, Kenny. We have a few minutes for questions before the webinar wraps up. So we'll just give everyone a minute to think about and write their questions. And if you have any questions you want to ask Kenny or anything that you wanted to circle back and ask Deb about from the first presentation, please enter your questions in that Q&A box you see on your screen. All right, well, we're not getting any questions coming in right now, so I think we'll go ahead and start wrapping up. If anyone thinks of any last-minute questions, please go ahead and enter those into the Q&A box, and we'll make sure to address those before we wrap up the webinar. And if you think of anything afterwards that we didn't address, that the presenters didn't address during the presentations, please feel free to contact me, and I can put you in touch with the presenters to follow up with you. So I think we'll turn it back over to Elise here to wrap up.
Great. Thank you so much. To both of the speakers, we really appreciate you taking the time to share your expertise with us. Deb and Kenny, and thank you, Paige, for hosting a great event. To all attendees, if you have any questions or you have ideas for future webinars, please contact one of the members of the WREN operating agent team, and their names are listed here on the slide. Karen Sinclair, Manuel Angier Copping from PNNL, or Jocelyn Brown Saraceno from DOE. And thank you very much.
All right, thank you very much, everyone. Goodbye.
Bye. Thank you.
Goodbye. Thank you.